Hello and welcome to Northwest Tower Engineering's Introduction to the TIA 222H standard. Purpose of this PowerPoint presentation is to review the differences between the G and the H standard, discuss when H will be required and is required, and discuss how it's going to affect your towers. So I'd just like to discuss how did we get to the current 222H standard. Back in the 2009 International Building Code, there was a reference to the G standard that we're currently working on, and this was adopted in July 2010 in Washington State and Oregon State. Obviously, it varies by state. So the new International Building Code, the 2018, will have a reference to the H standard. And so we've been reviewing the dates of adoption. So Washington State, the current date has been pushed all the way back to October 2020. And Oregon, it's going to be a year earlier, October 2019. And California is looking like January 2020. So the H standard includes several changes that can have a significant impact on the structural analysis we're doing on towers, particularly existing structures. Each state or local jurisdiction may choose to have more onerous design criteria than that referenced in the H standard. In particular, they may make changes to the wind speed maps. So what are the most significant effects on tower analysis? Big ones are wind maps. There are now going to be 4 wind maps. They come straight out of the ASC 716. So this is going to bring us right up to date. Typically the G standard has lagged behind, but finally we will be up to date with all the other codes and practices. Another big one is the risk category. This replaces structural classifications. I'll get to that. There are some changes in the way we can review the topographic effects, which can certainly help us. And seismic design is now pretty much going to be required on every tower other than on a radio tower, and it's very much the ASC 716 requirements. Okay, classification. G standard, we had 3 classes: low risk, then your substantial risk, which is just really your cell towers and broadcast, and class 3 is essential facilities. So that is being modified in the H standard and brings us up in line with the IBCs and ASC 716. So now it's referred to as risk category. You see we have category 1 and 2, pretty much the exact same as above in the G standard, but we now have a risk category 3 and a risk category 4. These were combined before, and now they're broken out. But we will be mostly using risk category 4, essential communication facilities, because it really will be a judgment call. Exposure categories, there's not really any change, so I'm not going to go into this in a great deal of detail. Hopefully you're familiar with this from what we were doing in the G standard. So here's just some examples. Exposure category B. So here's an example in a forest, and here's another example in a suburban area. So this just affects the ground roughness and really essentially slows down the wind speed. Exposure category C is the default category, the one we use the most. You see here we get some open terrain or grasslands. So this is still going to be our default, really. And finally, exposure D. This is really just Shorelines, mudflats, basically open sea. We don't use this one particularly often. The tower has to be pretty close to the water to force us to use this category. Okay, topographic category. So this is in reference to hills and the speed up effect that we see when we're on a hilltop. When speed up effects must be considered when a feature slope exceeds 10%. So anywhere 10% is not particularly steep. Under G standard, we had a very much a simplified method. It's now called method 1 in the H standard, and we're finding there is now a method 2, which is a rigorous approach. And we have found that if the slope is between 10 and 25%, which we would consider shallow slopes, that it can have a significant benefit to us. Now, this option is available in the G standard, and we have used it. It's called Topo Category 5, but we've got to be very careful using it. Okay, Topo 1. So Topo 1 is just flat or rolling hills. We got flat, rolling terrain. Topo 2 is an escarpment. Topo 3 is one we use a lot, and really it's the upper half of a hill. And obviously, once again, I mentioned the slope has to exceed 10%. So the problem here, obviously, is most towers get put on top of hills because that's where we get our best coverage. So we use this one a lot. And the final one is category 4 is for ridges, and we try not to use this one. We'd rather call it a hill. And this is the most onerous category. Wind speed. 3-second gust allowable versus 3-second gust ultimate. So under the G standard, we were using allowable wind maps. So there was actually only one wind map. But now under H standard, they decided to go with something called an ultimate approach. And just to be clear, ultimate is an engineering term. It doesn't mean it's the ultimate wind speed possible. So what the ultimate wind speed does is they actually took the allowable wind speed maps there, and they incorporate a 1.6 load factor and also the importance factor. And by using this approach, that's forced the use of 4 separate wind maps depending on your risk category. So it's kind of a little convoluted and confusing. And there are conversion tables in Annex L of the H standard that you can look up and convert back and forth between the various risk categories, and also with the allowable wind speed. You can, here's the actual conversion. So V at allowable, that's the wind speed allowable, is V ultimate wind speed times the square root of 0.626 divided by the importance factor. So the 0.626 is in fact the inverse of this load factor, and the importance factor, they don't tell you what the importance factor is anymore, but we've been able to derive that. Okay, here's these wind maps I've mentioned several times before. This is from, or is extracted from ASC 710. So this is a class 3 structure, which is what's called risk category 3 and 4. So you see in this map, here we go, here's Washington and Oregon, for example. It was 115 miles an hour. So There's 115, which was equivalent to 85 VSD. So the 85 was pretty much the wind speed we used over most of Washington, unless we were on a coast or in the gorge. So this, a lot of the West Coast it was this 115-85. Didn't really matter what county you were in. If you were in Oregon, they had a specialty code where they actually increased those wind speeds. Now this is quite different under the H standard. Here we go. So this example is risk category 4. There are separate maps for every single risk category. This is the most onerous with the highest wind speed. So you see it's 120 over this end. This does cover, the maps cover all of the US. I've just given the West Coast here. So we're going from 100 to 120. And so if we just look at an example, somewhere in Washington, it's 110 miles an hour, whereas before we were using 115. So you can see, even with this most onerous of wind maps, that we have dropped off the wind speed. What does it all mean? Wind speed, wind pressure. Because we have so many variables, we've come up with a way of looking at the wind pressure, and we have a spreadsheet that calculates the wind pressure depending on all these parameters. So wind pressure is 0.0256 times a whole bunch of coefficients times the wind velocity squared. So G standard, G, we had the wind speed, we had the structural classification, we had the exposure category and the topographic category plus the crest height. All those parameters multiplied out would end up giving us the wind pressure. Under the H standard, a little more complicated. We have some of the similar categories, but we have, additionally, we have distance from the crest of the hill, and this new one as well is quite interesting. It's the height above sea level, which considers the air density. The higher up you are, higher elevation, the lesser the air density is, and that factors into the wind pressure. Other changes are, this is design and escalating ice thickness. After reviewing this, there isn't any huge changes. G standard was based on ASC 705. And the H standard is based on ASC 716. So a similar approach in both, but we have new wind maps once again, and slightly different ways of looking at things, but it pretty much amounts to the same where we are. It says here, the ice conditions seldom governs maximum wind speed in the West Coast. The reason for that is, even though we consider much thicker much thicker ice conditions, the wind speed that we're reviewing is a lot less than we used to under the F standard. So it typically will not control, particularly on like a self-support type structure. Seismic load effects, we have to consider this. It's really becoming quite complex. It says it must be considered for risk category 2, 3, and 4. That's predominantly what we're looking at. The design is straight out of AS 716. So here is a chart. What we do a lot of the time is we actually compare the wind shear to the seismic shear. So that's where both these diagrams are. This is more up towards the top of the tower here. So here is the wind shear and with height, and this is the seismic shear with height. And you can see the two lines start to converge towards the top of the tower. So what that means is, for most of the instances we look at, we find that the wind will govern over the seismic. However, we would note there are instances where if you have a very heavy antenna at the very top of the tower, these lines can cross and seismic will govern. So that's part of the reason why we have to consider it. Foundations, H standard. Very similar procedures in place that we saw in the G standard. It has been reorganized, and new sections added. Obviously, we're now referring to risk categories. Now, I won't labor this one, very similar approach. So what does it all mean to you? How do these new factors affect the wind pressure when we compare H to G? When will you be required to comply with the H standard? Should you consider updating your files to the H standard? The importance of reviewing these parameters and how to incorporate spare capacity into your new tower designs. And also we'll discuss how we're getting dramatically different results under the H standard. Okay, so to do this, what I've done is take a tower. It's I believe it was a 280-foot self-support tower in Washington, and I'm actually moving it about to some different locations and reviewing the pressures and the capacity or stress ratio that we see. So the tower over here is more just an example of showing that we're in a valley or low site. It's not the actual tower I reviewed. So G standard, 85 miles an hour, 115. It's class 3. It's on the flat. Exposure B. So under the G standard, this particular tower was working just fine. It was at 77%. But when I review it to the H standard, and this is surprising, for once we're actually seeing better results. And the reason for that is the wind speed has dropped to 108 miles an hour compared to the 115. And this is for the most significant risk category 4. So what you see is my maximum capacity for this reduced wind speed is 68%. So I get a reduced member stress and increased reserve capacity. Here's the pressure diagram. This line is H, and this line is the G. So you can see that the H standard over the full height of the tower is slightly less pressure, hence the results. Next example, still on the west coast, we are on, I'm calling it a steep slope. Slope's greater than 25%. Keep some of the stuff the same. It's the same tower. It's 115 miles an hour. It's on a hill. I'm saying it's 1,000 feet tall. So when I move the tower to that location, it actually becomes overstressed. It's 130%. This is due to the wind speed up effect from the topographic factors. So I run it to H standard. I'm going with the simplified approach. Slopes are greater than 25%. It doesn't matter if I use method 1 or 2. So I've reduced the wind speed. The other interesting point is I've said it has 1,000 feet above sea level. So that helps us a little bit. So we go from 130 to 111. So we do reduce the member stress, so probably less upgrades would be required to H standard. So definitely an advantage. You can see here on the pressure diagrams, it looks like we got a little more separation between the two. So H definitely produced less wind pressure. Okay, this example, exact same tower. I've just moved it further east. This is in mid-Montana somewhere, another location where actually have done the tower. So as we go further to the east, the wind speeds actually were increased. So it's 120 miles an hour to the G, and to the H, wind speed is now very close. It's just 1 mile an hour less at this particular location. But what I do have is this height above sea level. You can see we're at 6,000 feet. So the only real difference between these two in terms of the analysis is to do with the 6,000 feet, and this reduces the wind pressure quite a bit. Here's the wind pressure. As you can see, H over here, G this side. So we're starting to see quite some separation between the wind pressures. And that wind pressure is actually dropped off the overstress quite a bit here. So definitely beneficial just from using the height above sea level. So I'm saying here upgrades may be feasible, or they certainly be less onerous than using the G standard. Okay, final example. So I'm calling this a shallow slope. Slopes are less than 25%. I think I've got something around 17–18%. Still the same, 15 miles an hour. 1,000 feet exposure B. So this is one of the towers we looked at earlier on one of the locations. So there you go, still 130%. But using method 2, the rigorous approach, my wind speed is down. I'm seeing I'm at 3,000 feet, so we know that's going to help. So the other thing that really helped was the slope less than 25%. So the shallower the slope, the less wind speed up effect that we have to consider, and that all plays into reducing the this velocity pressure. So here's the velocity pressure to H standard, and here it is to G, and once again you can see some nice separation here. So we're definitely considering a much reduced velocity pressure. Upshot, we went from 130 to all the way down to 93. So there you go, upgrades are not required. Okay, analysis of existing structures. Obviously very interesting to figure out when are we going to start running this H standard, or when is it required. But in general, if you change the type size or number of appurtenances on your tower, you will be required to run the H standard. That's really is the big one. Now this was added, section 15.5, and it talks about when the increase in demand capacity ratio of any member of the structure exceeds 5%, you are required to run the analysis. So here we go, section 15.5. So it sounds like an interesting clause that we might be able to use, but in order to calculate the demand capacity ratio, you really need to carry out an analysis of the structure, and you also need the original design to create a baseline to compare against. So without a baseline, a full comprehensive analysis is always required. So bottom line, it says if you don't change the load more than 5%, you don't need to do an analysis, but you need to do the analysis to calculate if you need to do the analysis. So we're back to square one. We also found Annex S. It has a further reduction in wind speed for risk categories 2, but the tower owner has to show that they are carrying out periodic inspections per the H standard. So this one will be very hard to police, and probably not going to be using this. Also, we found the maximum stress, or the demand capacity ratio. It says shall not exceed, that's 105% or 1.05. This was always the industry standard. We always allowed the tower to go up to 105%. People asked us where we got this, and it came from other building codes, but it's now in the G standard. However, although the standard only requires you to reanalyze the structure when there is a change in condition, we are recommended that perhaps for planning purposes you might want to start looking at this a little bit earlier. You could do this by even just having us create these wind pressure diagrams to see, are you going to get any benefit? Not all locations, like the example I showed, will have as much benefit. This is new, appurtenance mounting systems. Section 16 there requires a three-dimensional model. So what we've been finding is the carriers have been overloading these T-frames, putting a lot of very large antennas with radio heads up at the top of the tower. So now the code actually says, or rather the standard, a change condition would require an evaluation of the existing mount. So just be warned, we're going to have to start running a lot more mount analysis, which is something we're already doing for the carriers. Design of new towers. Right now we are going with the most onerous condition when we're designing these towers, which would be to continue using the G standard. As you can see from our early discussions, there's a lot that goes into specifying a new tower. You got to make sure you have the right wind speeds, all the correct risk categories and exposure categories, distance from top of hill. So we strongly recommend that you have a design professional write a technical specification. That way when you go out to bid, you will get an apples for apples comparison between the tower bidders, not just whoever chimped out on these categories and parameters. You can also build in some additional capacity. You can, a lot of the time we're saying we're looking at not exceeding 85% capacity on the tower, on adding additional loading, or even increasing the wind speed above the minimum wind speed specified in the code. You can also consider increasing your tower height even if you're not building that. Inspection of existing structures is also discussed. This is not a great change from the G standard. It's all specified in Annex J, but you can see the return periods. Guide towers 3 years, self-support 5, and also note a shorter inspection interval may be required for risk category 3 and 4. So you see, it's a good idea to go out and look at your towers. And a summary conclusion, the G standard is still in effect and does not come into effect until each jurisdiction adopts the new IBC. Changes to code such as a higher wind speed may be made by certain jurisdictions, and this could have a major impact on the final results. This is another reason why we cannot use the H standard yet. We do not know what's going to happen or what changes will be in there. Should note that H standard is very complicated, even more complicated than before, but there's a good chance we might have some additional capacity. So don't forget, think about your planning, compiling databases, looking at these wind pressure diagrams, and also some towers that were major upgrades or failed under G standard, they might just pass under H, so it's definitely worth looking at. And a reminder, it's critically important to specify the parameters on all your new towers. Very difficult to do, and we also got to look out for any local requirements that may be in excess of H. So hopefully this was helpful to you. I appreciate you listening in. Thank you.